Hello, everybody. Apologies for getting started here a little late today. I think connection is okay, but for those of you who are having some problems, I put a little bit of a warning in the chat there. Like I said, I was a little bit behind schedule, so I am just kind of pulling up terminal so that we can be prepared to start today. What else? The assignment, I think, was due either Saturday or yesterday, or at least the late deadline. I think most everyone was able to get that assignment resolved. There were some confusion. There was some confusion. But I think most of you asked me questions. So I'm glad that we got that done. Do you guys have any questions right now in regards to operator overloading? I will say that we were using pointers in that. Let me even pull it up here. It's probably a good idea just so we can look at it. I guess I'll keep that one open. So we were using these. Which were 4 pointers. And really, there was no reason to do this. It probably would have made more sense for all of you if we did these as just regular integers. And of course, the integers would not be equal to null, but rather to something like 0. But the reason that I wanted them to be pointers was because we were overloading some things and we were practicing our rule of 3. So we had to do a copy constructor. We also had to do an equals operator overload and a destructor, as well as some of the operators require you to declare a new matrix or to adjust something that was already within that matrix. And so these should have stayed pointers. And this was to help you practice the idea of this dynamic memory allocation that's going on, especially when we're working with things like classes that contain pointers. Now today I will code up a matrix class that uses this thing here that I talked about. I said I'd give you some extra credit if you replace these 4 pointers with just a double pointer and then actually worked with that matrix. Today or on Thursday, I will code one of those in front of you just so we can see it. But it will be more tied to the template discussion, which is what we're starting with today. And so there will be another assignment that goes up today. Let's see here. So macro says I did a double matrix equals new int. Was it a double? I mean, that might work. In terms of the math part of it, I'd say if a double is equal to 1, and the int is also equal to 1, then it might work, but I might be worried about that because, well, as long as you had no memory issues, I won't mark you for that. And as long as everything works, I'll look to give you extra credit there as long as you were working with that double pointer. And just so you know, if we were to do that, it would look something like this, where we've got probably our matrix, and initially it would start out pointing to null. And then in our constructor up here, what that might look like. And so as long as you were close to this, you'll get full extra credit. Also, as long as there were no memory problems. I'm going to zoom this out just a little bit. Hopefully you guys can still see that. Please let me know if you can't. So this would be the constructor. And so the first thing that we would have to do is we would need to allocate that matrix there. Now this is a double pointer, and so a double pointer can work like this. In which we can access not only one bracket, but with two brackets. And so let me ask you guys, if whatever this is, and I'll put it in parentheses, I'll even just zoom in a little bit. This thing here in parentheses, if that thing can be addressed or it can be operated on by using these brackets, what do you think this thing returns? So, and while you guys are thinking about that, I'll just kind of remind you how this might look. So our matrix would look like that. It's probably good. And here we've had like X, maybe Y, maybe W, and maybe Z. And so this matrix is what it looks like. And so kind of, if we're talking about indexes of this would be 0, 0. This would be 0, 1. This would be 1, 0. And then this would be 1, 1. Right, where this is located at 0, this is located at 1, and this is located at 0, and this is located at 1, right? So that's kind of what the matrix looks like. And in here, we're going to be storing some integer value, like I said, X or Y. And so the way that this works, the way that a double pointer works, is it's a little confusing. But what you actually have is this double pointer, which is actually a pointer to a pointer. It's a pointer to a pointer. So the first thing we do is we allocate an array of pointers. So you would say something like, and if we're already in our constructor, so I'll say something like matrix is equal to a new int. Now recall that this is a pointer. So I said it's a pointer to a pointer, and this is the double pointer. And since, let me kind of pull up a paint diagram actually. So the first thing that we're going to do is matrix is going to point to an array of pointers. And that is the first dimension. So let me get some colors going on here. Here's it's pointing and it's red, white, and blue. And so then we're going to say that this is going to be probably new int. Like I said, this is the code that we're writing 2. Because we're making a 2 by 2 matrix. So we're going to say this is new int 2, which means that we've got a matrix located at 0 index. And we've got the matrix located at the first index. Now these are pointers here. Let me see if I can even zoom in a little better. So these are pointers here. And so now what we're going to do is that we're going to then point these pointers to new ints. So let's go ahead and open up that. And in general, you would use a for loop for this, but we won't do that. So what this handles is the first dimension. Dimension number 1. Now we need to do the second dimension. I don't know why it's doing that. And so we'll say the matrix in the first position is equal to new int 2. Now this is not a pointer, right? Because these are actually just ints, right? So these ones are just ints, and this one is a pointer to a pointer. So this is a pointer to a pointer, and this is a pointer to an int. And so then what we'll say is matrix 1, I guess it doesn't like that, is equal to new int 2. So that's the second dimension, in which we allocate an array of ints into each of these pointers within the array. And so then if we come to this Microsoft Paint diagram that I was working with, and we grab another arrow, whoops. These are then going to point to 4 ints. So we've got an, this will be an int, just like that. And then this one will also point to an int. And so then all we have to do to get to our matrix is draw a line through here, right? And draw a line through here. And so if we want to get to the upper left, we need to go into 0, and then we need to put the brackets further on this guy. I'm going to kind of do it here off to the side to get into 0 there, right? And then to get onto the other side, we need to bracket it at 1. Does that make sense? And so that's how you work kind of with double pointers. And there was a bonus question on the test in which I asked you how to deallocate this. And so then in order to deallocate it, I will put that maybe in green just up here at top, where we first have to delete, and we're going to do the bracket delete because we're deleting arrays. Matrix 0. And then we have to delete matrix 1. And then lastly, we have to delete matrix. Okay. And that's the deallocate code. And so at the end, I guess I'll save this little diagram I've made and upload it to Web Campus. But if you did anything like this or close to, you'll be eligible for some of that extra credit, even if they are doubles. Because the output should still be the same. So hopefully that kind of makes sense. And then we're going to go ahead and jump into our new topic today, unless you guys have any further questions. There's one thing that I did forget here, and so I just kind of want to throw it in. We're going to make this a new int 2. We're going to make it a little smaller. Now we'll go right there, about. All right. So today we're talking about templates. So these are actually my backup notes. So I'm actually going to move them over to something else here. I'm going to move them over to my other notepad so you guys aren't seeing it, and then I can type it along with everybody. And hopefully we can kind of follow along what's going on here. And I've got plenty of examples for this. If you couldn't tell. All right, new file. All right, and we're going to go ahead and start coding our just example code so we've got something to compile. And we'll also have our int main. And then it looks like these are notes from last time, so we'll close those. And then that looks like the shopping list. I know, you're so cute. All right, today we are working with templates, which is something that we've worked with before. So let's go ahead and start with what is a template? Make sure you guys can see this. So simply put, this is a function or a class. Function or class. I guess I'll put the or there instead. That is equipped to handle a generic type. Or multiple times. Or multiple types in that sense. And so what do we mean when we're talking about generic? Generic or general? This is something you'll hear a lot in computer science. And this just means the simplest representation or solution of something. So if a function is general, then it's equipped to handle a wide variety of cases. If something is very specific, then it's only equipped to handle one or two cases. And so templates are general, and they're very helpful to us. And so we will get into an example here. But first thing we need to know, what do they do? And we can tell the compiler, or rather we can declare types and functions to work with any type of parameter or member that we want. And so that means that, just for example, sorting. We can write a single function to sort an array of any type. Just a single function. And so that could be a strings, could be strings, could be ints, and it could even be declared types, right? The AIS type from homework 1 and 2. We could do our matrix 2x2. And these are just user-defined classes. So let's go ahead and get started. There's a few things that we need to talk about syntax. And if anyone's feeling brave today, and I'll reformat this in a little bit. Never looks nice. Especially when I'm trying to make it big, but that's okay. So if anyone's feeling brave or they have any ideas, there's one template that we've used before in this class. Does anyone know what that template was? And in the meantime, we're going to get some syntax going. And there's a few things that we need to do. So we'll say for functions. Template type must be in the parameters. And for classes, the template type must be a member variable or function. All right, thanks for trying. I'm thinking of a class type. I would say that string streams they have templates in them somewhere. So I'll give that to you. Size of is a great guess. Size of actually I think is a template function because it takes all types. So that's great. Yeah, so I'll give those guys to you. But the one I'm thinking of specifically are vectors. And do you remember kind of what those look like? When we want to make a vector of a certain type, we'll say something that's like this, or we'll say something that's like this, right? And this is where we declare the object and we include that type within those brackets to say, hey, this object is going to be working with string types. Okay, so we're just going to do our syntax real quick, and then we'll start with our basic example. So the syntax for functions, and we're also going to say one thing. And like I said, I'll clean these up. I'll put in lines, especially this one because it's going to get a little nasty here. But I'm going to say type name and class are interchangeable. So these are keywords. So pick your favorite one and remember it. And let's start with template function, probably number 1 here. Yeah. So for function, what that looks like is we're going to say template. And then how many types are we going to equip this function to handle? How many different types that is. So we'll just kind of do this thing where we'll say type name, type 1, and then ... to continue on how many there are. And then we're going to say whatever the type is, and it's not this same type. Function type, function name, parameters, and then body. So this is the only thing that we're adding here. And for a class, it looks the same. So I'll even just copy this here. And it will look better as soon as we start putting it in some actual code. But you'll have this template. And then this is not going to be a function, but rather it's going to be a class, class name. And in here, it's going to contain whatever these templates are. So we'll go ahead and get started with something simple. And so this example is going to be very basic, all right? In fact, we're going to do the less than sign, which is something we've done, which is something we're already provided with for most things. But just to show it to you. So if we're going to do a function called less than, it's probably going to return a true or false, and it's going to tell us if two objects are less than or greater than. So if we're going to do ints, int A and int B, we could return something like A less than B. Now, some of you guys might prefer to type it like this, right? If A is less than B, then return true. This might make a little more sense to some of us. Else we'll return false, right? And so that's what that would look like. But notice that this is only equipped to deal with ints. And previously, if we wanted to do something about that, we could then employ a function overload in which we could copy it right here, and we could say, hey, this one is for strings. But now look at how kind of ugly this has become. Now we've got two functions with the exact same name that take different parameters. And look, this is the exact same code. This is the exact same code. So is there any way that we can make this simpler so that we only have the one function and we can just say, hey, compiler, it's your job to fill in the blank here. I want you to do the exact same code, but it's your job to fill in the blank. And so that's where templates come in. And so considering the notes that I just wrote, which I will clean up later, we're going to type template here, and we're going to put these brackets. And then we have to include whatever the type is. So it's either going to be the type name, like I said. This is my favorite one. But class is also interchangeable here. So you'll see this both if you're Googling code and stuff. You'll see both implementations, and the class and type name are interchangeable. They're the same thing. So you type name here, and then we're going to give this a name. It can be T, it can be James, it could be T1. This is completely up to you. I always like to do this, type 1. And even if we're being pickier, maybe it's lowercase. And so now we're just going to go into this function, and everywhere that we see this type that we want to interchange, we're just going to put that there. Okay. Now I want to specify this. For functions, the template type, whatever it is, it must be in the parameters. It must be in the parameters. There's no other option, okay? It has to be in the parameters. And what I'm saying is if I made a template type here, and these were both integers, and then somewhere down here I said like type 1 Bob, and I just declared that variable somewhere, there's a problem here. And the reason is, when we're somewhere in main, and say we've got int, I1 and I2, and we'll just declare them to be something like 3 and 10. 120, I guess, is good as well. And then we can also do something like strings. S1 and S2. And we can do my favorite ones as always, Loaf and Patty. And then let's say I want to do my if statement here. So we'll say if less than. And so we'll pass I1 and I2. Then we'll just see out less than. Else we'll see out greater than. Greater than or equal, I guess. So the problem here with this is that notice that this is taking ints, right? In the parameters. But then what is this type? What the heck is this type? And when I call this, I'm passing the two ints. But then it's going to say, hey, what do I put here? What type goes here? Now with the vectors and the classes, they work differently. With those, that's when you would say something like this. But it doesn't work that way in C++, at least for the functions. At least I don't think it does. We're here to learn anyway, so let's just go take a look. Why not? Oh, all right. Today I learned something myself. Let's see if it works. Oh man, okay. That's great. That's great. I can change the notes. But notice here I should get a compiler error on this because I'm not specifying what that type is. So let's verify that. All right, and there you go. And then let's see what this error says. It's a little small. I just kind of want to... Okay. So here it says, template argument deduction substitution failed. Which means that it says I cannot substitute whatever this type is. Or it must be specified with brackets. So does that make sense? Hopefully it does. And so if I'm going to do something like this, I have to specify what it is. But we're not going to start with that. In fact, we're just going to make these types. And then down here, we're going to do the same code that I was doing, except now we can call the exact same code with Loaf and Patty, right? So that's going to be string 1 and string 2. So let's compile this code, and we will see that this one function can compare both the integers and the strings very easily. And that is our general solution. And it's general because we've written only one block of code to handle many cases. Notice it compiles. And then if we run our code, I'll make it bigger. I guess loaf is less than patty, alphabetically. And so there you have it. So are there any questions in terms of this function? And I should clean this up. If the template type params, then the function must be called with the type specified in brackets. And then always for this, always the class will be declared with the type specified in the brackets. Now, overall, this is pretty simple. Ha! Isaac, that's a great question. So Isaac asks, is there any type that wouldn't work with your less than function? Now, the answer is yes. And the answer to that is yes. And I want you guys to remember this. I asked this kind of question on tests and stuff. So what kind of types would not work with this function? Well, notice that there's only one operation within this function here. There's only one operation here. It's right here, right? And so by just looking at this operator, hint, can you guess what types wouldn't work with this function? Anybody? I'm gonna ask you because I really want you guys to think about that. Of course, I'll give you the answer in just a moment, but if you really want to try, this is an operator here. So in what case would this function not work? Hint has to do with this operator. And while that's with bools, that's okay. I think false is 0, and true usually evaluates to 1. So I think false less than true. We could try it. I think we'll return true. Yes. Okay. So Aaron's talking about it, right? So Aaron gets it, and Peter gave him the arrow there. T. Peter gave him the arrow. So that is correct. So any class, any operators that we use within this template, this operator needs to be overloaded. It needs to be overloaded in any of those classes that we define. So I'll put it here. Well, I'll put it in the notes, and I'll clean it up after. Kind of just a note down here. This is a big question. For any operators used in the template functions, if the template is used with a user-defined class A must have an operator. So we'll say for any operator O, how about we call it that? Any operator O used in the template functions, if the template is used with a user-defined class A must have an operator O overloaded. So in this example, if we did something like student, we did something like, hey, struct student and we said, you know, whatever, private string first name. And I'll even show you the compiler error. So let's just say we have this, okay? We just have this struct student, nothing really going on here. And so now if I come down here and I say, hey, student, I guess we'll call it U1 and U2. And obviously I didn't, I didn't have a constructor or anything, but I'm just showing you the compiler error, that's it. So I'm going to try to compare these things. So it's going to substitute these two types for students, and then it's going to look at this operator, and it's going to say, hey, can I do that? And the answer is no, because we haven't overloaded that less than sign for this student. And so then when we go in here and we compile it, it'll say, hey, this is wrong. I don't like it. You get this really big, we've talked about this disgusting error before, right? We talked about this disgusting error. And if you go searching for it, you can kind of see it's kind of in places here, right? Operator less than. We can kind of see what's going on. So how do we fix that? Well, we have to overload that operator. So we'll get to that in a later example, but I'm so glad that you asked that question. And very good job. Very good job. So then Aaron had asked the question, is the constructor that is a template with vectors? So I'll tell you, we'll get into that, Aaron. In fact, the whole class is a template, and I'll show you why. Because kind of in our notes here, we talked about there's a syntax specifically for functions and a syntax for classes. And so I'll show you kind of what that means. So I'm going to need a new file, and I'll give these names. I always like to do that. One will be template functions.cpp. One will be template classes.cpp. All right, so here we are. Let me grab my favorite stuff. Always like to have that, and then let me grab this. Okay. So I kind of want to work on this matrix class. That's kind of what I want to do. Let me see what I have for my notes instead. Maybe we can start out something a little lighter. Not a fan of that one. So what do you say? Let's do a very simple, well, let's do the matrix. I'm really debating with myself right now if I want to do that. It could be fun. But I don't want to stray too far away from the template, so we'll see how it goes. Please stop me if you're confused at all in any way, because I'm only trying to be helpful. So notice here's that code, right? So I just copy it here, and now I just got to clean it up a little bit. So in the case of a vector, there's only one type. So we'll just start with one type. We will talk about maybe next time or maybe today, depending on how far we get. I'm not going to spend too much time on the matrix example because that class could get really big. But we could always add additional types. And so I'll definitely want to talk about that at least before we move on. So we will get to that. But let's just kind of look at a matrix. At least some of the basic things that we would talk about. So if we have a class matrix, as I said, the entire class is a template in a way. So it's a matrix of some type. It's a matrix of some type. And so what does the matrix hold? That's kind of the question we ask. What does the matrix hold? Or what does the vector hold, right? Is the vector holding ints? Is it holding strings? That's kind of what we ask ourselves. And so just like with a dynamic array, which we've coded before, right? We did, in fact, it might be easier someday, maybe next class, if I could find that dynamic array. Be very easy, in fact. We talked about it before the test. So I could just pull this. This is on our notes. Notice that this dynamic array here, and look, I kind of talked about the vector int up here. This dynamic array is holding a pointer to integers. So if we wanted this to be a template dynamic array, this would be the type 1. Now this is a big hefty example. So really all we'd have to do to convert this is go through everything in this class and turn everything that deals with the array into a type. Very simple, very simple. So in terms of the matrix, we're going to do that exact same thing. So up here in the private, we're going to have not an int, but in fact a type 1, and we'll do the double pointer. A little spooky. We're getting a little spooky here. This is going to be our mat. This is going to be our mat. Maybe it'll be lowercase matrix. And let's go ahead and initialize that bad boy to null, because it is a pointer. And now, just like with the dynamic array, this matrix has a width and a height. Now, the width and the height are integers, right? They're not of this type here. They have to be integers. So we'll take the width, and we'll start that out at 0, and the height, and we'll start that out at 0 as well. Okay. So those will be our only member variables that we have in this class. And so let's go ahead and just do maybe a constructor, a destructor, and then maybe a print, and that's all we'll work with for now. And then maybe we'll come back and really develop this class later, but that's a good starting point. So I'm actually going to skip the default constructor because I kind of handle it here, right? Though it might not let me do that. So maybe I won't skip it and I'll just put it like that. Notice that these already get initialized here. And so we could just leave the default there. Now this one, in the assignment I had passed in 4 integers, right? But instead what we'll do here is we'll pass in just a width and a height. Say width. We'll call it W, and we'll pass in an H. And then in this parameter, or within this parameter constructor, we will initialize all the values to be some default value instead. So this will be our parameter constructor here. And so let's get started with that. And so we can initialize the width and the height to be some values, right? So the width here can be of W, and the height can also be of H, right? So hopefully that's not, that's obvious, right? We've been doing that for a few months now. I don't know what I just did there. We've been doing this for a few months. And then now we need to allocate this array. Now we need to allocate this array. So if we kind of look here at this thing that I did, we're just going to kind of replace some values in here. So this 2 here is probably going to become our width. I just put it right there. And then these values down here are going to become, this becomes our height. I apologize. The height comes first. So this one becomes our height. This one becomes our height here. And then the other ones become our width down here. That's the width and that's a width. So we'll go ahead and code that up. It's a good one. All we'll say here is we've got the double pointer up here, right? And it's a type 1. So if this were to be a dynamic or a matrix for only integers, we might say something like matrix is equal to new int pointer of the height, right? But this time we're dealing with this type here. So we can just put it here. Does that make sense? And so now that we've allocated this value, I'm going to do a for loop. So notice here in the paint diagram that we did, notice here in the paint diagram that we did, for every row, I have to allocate the columns. For every row, I have to allocate the columns. So that's all I'm going to do. I'm going to say for int I is equal to 0. I is less than to the height, less than the height. And then I++. Gotta make sure I get my spaces there. I then need to say matrix that's located at I is now equal to a new type 1 of the width. And now it's allocated. Are there any questions with that? Is that confusing? I know it's a little spooky. This was kind of on your test, though. I don't know if you remember this kind of question, but I kind of put that on your test. So we've been talking about it for a little bit. It's just a pointer to a pointer. And we're allocating arrays into each pointer. And so now we're going to initialize these to some default value. Does anyone have any ideas how we might do that? Let me go ahead and do the for loops first. If you have any ideas, let me know, and then I'm going to try to give you some hints, because I like doing that. So this is going to be J's instead. My face is probably in the way here. Let me fix that. And then this is going to be the width. The width of our matrix. And then in here, I'm going to say something like this. Matrix I and then J is equal to what? So I'm asking you guys, what do I put here to initialize it to some default value? And I'll give you the hint. And the hint is default constructor. Oh gosh, I lost it. Why did I do that? You guys probably watched me do that. I'm sure you guys did. So this matrix is of type 1. So if it's an int, then the default value is probably 0. If it's a string, the default value is probably quotes, right? Or empty string. But what if we don't know what the type 1 is? If we don't know what the type 1 is, we can't say something like this, right? We can't say is equal to 0, because what if it's not ints? We can't say it's equal to this, because what if it's not strings? So that answer is, all we have to do is this. I'll put that in the notes. Is that okay with everybody, what I did there? All I did was I called the default constructor for whatever that type is. That's all I did. And so if we're working with ints, this is going to be the default constructor for ints. If we're working with strings, this is going to be the default constructor for strings. If this is a student class that we have developed ourselves, this will be the default constructor for strings, or students. Sorry. Too many S words. And so let's just start with that. I won't do... We've only got maybe about 20 minutes left here, so I'm just going to kind of start with this basic matrix. We'll do a destructor, and then we'll do a nice print statement, and then we'll just kind of work with it in main, and then that will probably be our class for the day. I will be introducing the new assignment at the very end. I think this one's kind of fun. You guys should be able to get started on it. But let's go ahead and work on some other stuff here. So recall that this matrix here is a class that contains a pointer, so we should follow the rule of 3 always. We won't get to it today. So we'll just start with the destructor. Now this was the test question. So you can always come reference these notes if you'd like, or you can go check the test question, because I put it in there as well, I believe. All we have to do is deallocate the same matrix, and it's backwards. So it just happens backwards. So notice I just copy pasted the allocation code. So all I'm going to do is this. And so now it's like I've allocated it backwards. And now I'm going to deallocate it backwards. So notice here that we allocated an array. We allocated an array here. So I'm going to delete that part. And I'm going to replace that allocation within a delete array. And then notice that I allocated an array here. So I'm going to replace that with a delete array. And that's that. It's done. And that matrix is now gone. Please let me know if you're not okay with that one. That's how I like to think about it, is just go backwards. This is the forward direction for the allocation. And this is the backwards direction for deallocation. If we happen to delete this one first, then we wouldn't be able to access these guys. And we'd probably get seg faults. Maybe not. Maybe not seg faults. Maybe if we set it to null first, but this is how we deallocate that. So now let's do a nice print statement. So we'll call this void. And what will we do here? Let's say something like print matrix constant, because we're not going to alter anything within our array. And I'm going to make strings, I guess. And I'm going to put this little kind of bracket there. And I'll say for... do I want to do that? I don't think I want to do that. Let's do a cout instead. Let's just do a cout instead. We could even pass in that iStream. Let's do that since we're working with stuff like that. Or it's going to be our outstream. So let's send out this line, and then for int I, we'll do j is equal to 0. J is less than our width. J++. We'll then send out a space. We don't need the space. Let's just send it the value. So this is going to be matrix located at ij. I haven't done the outer for loop yet. My face is probably in the way here. So I'll do the other for loop in just one moment. And then I will print this thing. Okay. And then I'll put my other for loop up here. I could just go copy it because that makes life easy on us. And then at the end of that for loop, let's go ahead and out an end line. So let me ask you guys, in what cases do you guys see any potential problems? And I'll give you the hint here. We talked about what types wouldn't work with this function here. So if we're looking at this print matrix function, do you guys see any potential issues along those same lines? And if so, with what? What do you guys think? Recall that this here is our template type. The matrix ij, that's our template object. And are we doing any operations? Are we calling any operators on that object? I'll give you a few more seconds here. I believe in you guys. Aaron's got it, I think. Again, with classes we created. We don't have an overload for the insertion operator. That's exactly right. It's this thing. So, this probably works maybe with your vectors. You have to consider that. I'm not quite sure what the vectors have done. But if we make a matrix for students, we need to overload this thing. Otherwise, this print matrix is not going to work. It's not going to work. But otherwise, that should be good. So let's go ahead and test it out. What do you say? What do you say? I'm going to just kind of put some end lines here. Just so we can kind of see what's going on. So let's just make a few matrix, and then this will be as far as we go for today with the matrix stuff. Now recall that I have to declare it. This is a class, okay? This is a class. And because it is a class, notice that this is the parameter, right? This is the template parameter. Sorry, template member. And so since when I declare just a matrix, the matrix has no idea what it is until I say something like int m1. And then I could call m1.print matrix, and let's pass it cout. And then I can make another matrix of strings. And then we can print that one. And then if there's any other type maybe that we could consider, and it could be anything, right? So really we only work with bools and doubles, but we could do a double, I guess. M3, M3. So let's see what we get. We should see zeros. We should see nothing because of empty string, and we should see zeros. Let's give it a shot. And if you guys have any questions kind of about what we talked about today, now's the time to ask them, because I will quickly pull up that assignment just to show you that it's up there. And you're welcome to get started on it any time. Well, it's not up there yet, but it will be. So I compiled nicely. But something weird happened here. Something weird always happens. I don't understand why. So obviously I should have seen some zeros here. So we'll just start with that. Something always goes wrong. I'm not perfect. I'm sure you guys know that. Oh, you know what it is? You know what it is? I'm goofy. I am goofy, as I like to say. There's one thing that I wanted to do, and that's probably let's make a 3x3 matrix. Let's make a 5x5 matrix. And let's make a 10x2 matrix. I get ahead of myself a lot. Now that would make sense, right? That would make sense. Exactly. Awful nailed it. You got my back. You see what's going on here. I'm just making goofy mistakes. And I got a seg fault. Of course I did. I assure you that it's nothing crazy. What do you think? I put the numbers into the string. Well, this is a height and a width. So I want my matrix to be a 3x3 or a 5x5 here. And so what I should have done up here is that the width and the height would have been initialized, and then we would have made height of 5, and then we would have made a width of 5. And so I'm sure that I've got a goofy mistake somewhere. And you know, like I said, I will stay after class just to figure it out. Let's quickly val grind it. Why not? Just because I don't see any reason why we shouldn't. And what does it say? What does it say? It's a little small. We have an invalid read. And yours ran? What? Why? Why did yours work? Why did yours work? It's telling me line 42 maybe. I've got some issues here. Line 42. This definitely, I think, should have worked. Oh, I see. Do you see my goofiness here? This is what I get. This is what I get for copy pasting everything. This is what I get. Notice it told me line 42 though. It told me what line 42 was, so I went and looked there, and it gave me something to go off of. There we go. Okay, we did it. We did it, folks. We made it. I put an I there instead of a J. But look at our pretty matrix, our pretty matrices. And if I even val grind it one more time, I should see that all leaks were freed. All heap blocks were freed. Okay, so we're all good on the allocation part. And look, we've got a 3x3. Notice they're all zeros. They're all zeros. And why is that? Well, that is because we initialize these values to be of type 1. Default constructor. What are these? These are empty strings. We can't even get in there because there's empty strings there. And why is that? The default string constructor. And then, of course, these are the doubles, right? But doubles, default, are also just zeros. So if I ask you on a test, and I will put this in the notes, init, how to initialize template type and we do that with the default constructor. So I'll put that in the notes. But while we've got 4 minutes left here, I'm just going to pull up the assignment real quick, show you what's going on here. This one should be fun. Well, I at least hope it is. And by the way, I will get to the extra credit and assignment 6 sometime this week. I've been very busy. So I hope you guys understand. But of course, I'll always answer your questions if you have them. So we're going to go here is what we're going to do. And we're going to go to assignments. So this one has to do with templates. And what we've done in this assignment is we've kind of incorporated some other things from previous assignments. So hopefully you've been following along. And if you have been, this should not be too bad. I've already given you quite a bit of the code for a lot of it. But here we go. Oh no, there's trash everywhere and it's all of different types. Let me pull up my stream here. It's all of different types. And just from this lovely picture that I've made in Microsoft Paint, we can see that we've got ints, strings, floats, and characters. They're all on the ground. And we're going to have to pick them up. And so how this works, I'm just going to give you the overview since we don't have too much time left. There are 4 classes. There's 4 classes. And you're going to have to put a little bit of code in each class. Notice here we've got an abstract class bucket. Okay, this is like a garbage bin. It's like one of these things. It's either the pail or the bag. And so you have to add a little bit of code for that. And then we've got what's called a static bucket and a dynamic bucket. The static bucket is like a bin. It can't grow. It can only hold so much stuff. A dynamic bucket is like a bag in which it's flexible and you can kind of keep shoving stuff inside of it and it will keep growing and growing. Now, did we already code something that's like that? Yes, we did. The dynamic array. So you've got that code. Okay, so take a note of that. The dynamic array class that we coded in class will help you with that part of the assignment. And then finally, we've got a class garbage processor. And so you guessed it. These 3 classes are template types. They're templates. And they're just arrays, okay? And so all you'll do, it's very easy. Well, at least I think so. So I guess I won't say that too quickly. Is here we've got this. This is the input file. And so you see we've got characters, ints, that's a decimal. That's a string. Those are characters. That's a string. We've got a General Kenobi going on here. I got my brand buying RSGF. A bunch of stuff going on here, okay? So this is just a bunch of garbage. And so we're just going to read in line by line. We're going to say, hey, is this a character? Is this a string? Is this a decimal? Or is this an integer? We're going to determine which one it is. Put it in the appropriate bucket, which are going to be templates. And then in the garbage processor, we're going to call sort, and we're going to sort all of the garbage, all using templates. And so that's that. If you guys just want to give me 1 second, that's all I'll talk about. There's one thing here. There's an easy write-up at the end. Just as we're coming to the end of the semester, I want you guys to kind of know what you're talking about. And so we kind of even already answered some of these questions today, especially 2 and 3, and number 1 is in the notes. So if you can just make a text document and answer these 3 questions with 1 sentence, they don't even have to be complete sentences. I will give you some points for at least knowing what you're talking about. And so if you just hang out for 1 moment, I'm going to give it a run. And then next class, I'll at least pull up the skeleton code. But I do want you guys to at least take a look at it and get started. But while we've got, negative time here, I'll just try to run this code in front of you guys. And if you're okay not seeing it yet or coming back, you're welcome to head out for the day. I just kind of got to find where I was here. Because sometimes I get lost. Oh, this one will be good. Hopefully this one works. I hope it works. It should work. Let's take a look. So, how do I compile it? How do I do that? I forgot. It's probably just going to be G++, main. I guess I closed it. But we'll reopen it. And we'll just verify how to compile that. Way down here. And there it is. I'll just copy it. Should work. And if I run it, /a.out. Oh, I have to provide the file name as a command line argument. I don't know if we've done that before. I think you learned that in C++ or in CS135. All right, and so all we do is we display the bins. So these are the int bins. Notice it's all sorted. We then display the decimal bins. Notice it's all sorted. And these are decimals, I assure you. They are decimals. They're just displaying like that. We sorted the character bin, and then we sorted the string bin. Okay? So if you've got any questions, you can come to office hours. You can ask them now. But that's all I got for you today. I will post the notes cleaned up, some of our code, and next class we'll spend some more time on this. And I'll give you guys until early next week to do this. So you'll definitely have the whole weekend to work on this assignment. And that's that. So thanks for coming to the stream today. And Aaron, I will go over that next class, if you're okay with that. Like I said, I didn't get to everything that I wanted to today. But I will show you, and it's very, it makes sense. It's all I'm saying is it's kind of obvious based off of what we learned today. In this assignment, you won't have to deal with the multiple types, okay? Yeah, in this assignment, you won't have to deal with the multiple types anyway, but I will show you that next class. Good question, though. I'm glad that you're thinking about this stuff. It makes me happy. So that's what I got for you today. And look for everything. I'm going to upload it all in the next hour. And I'll catch you guys on Wednesday. Have a great rest of your Monday. Go out in the sun. Get some rays. And I'll catch you guys next time.